Okay, so let us start. Do you have any questions from the previous class? Any questions? So Lagrange's method of multipliers. So this forms the last topic of differential calculus. So the questions, actually you can expect questions from this section. So this is Lagrange's method of multipliers. So this is actually one way of finding out the maximum or minimum value, right? So but actually there are certain limitations to this, and there are certain great advantages to this particular topic. So that is, so we are finding out the maximum value or the minimum value for any given random function f of x comma y. Suppose if it is f of x comma y, z is equal to, then actually we found with the help of Taylor's expansion the conditions that are required to find out the maximum value or the minimum value. But what if this function w is equal to f of x comma y comma z? Now for this kind of function it will be very, very tough to find out all the conditions and then to prove those conditions. But obviously there will be an advantage if there is a difficulty. So the advantage there is, so you will be able to find out all the aspects, that is what are the points that are there, and what are all the points where you can get the maximum value, and what are all the points where you will get the minimum value, and what are all the points where there are saddle points. So all such kind of information you will get to know. So if provided, if you apply Taylor's expansion for multiple variables and then try to take all the conditions, and those conditions you have to derive it, and then we proved only for the 2 variables, but for 3 variables it will be much more difficult than that. So lot many aspects that you need to take care. So to avoid all these things, Lagrange has given a beautiful solution. That is, suppose if there is a constraint, so this Lagrange's method of multipliers, so it will be applicable for multiple variables and constraints. So till now whatever we have discussed is applicable only for the 2 variables, right? So z is equal to f of x comma y, where we are finding out the maximum value or the minimum value for the z. Now here actually if there are multiple variables are involved, then Lagrange's method of multipliers is the best method to go. But there is a limitation for that. The limitation is, that is, so it will give only one solution. It will give the solution but it will not give clue. Clue if it is maximum or minimum. It will give you a solution. You have to identify based on the physical situations whether it is a maximum or minimum. So this is a limitation. Now actually, but actually it's not a very great limitation, because you will be able to identify whether it is a maximum or minimum based on the physical scenario that was described in the problem statement. So this is having the greatest advantage, that is Lagrange's method of multipliers. That means there are some multipliers that are coming into picture. Now let us say there are 2 different functions that are involved in this. One is 2 functions involved. So first function is the function to maximize or minimum. The function for which we need to find maximum or minimum. So this is usually represented as f of x comma y comma z. So this is the function actually which you need to maximize or minimize. Now the second one is, so you may be having 2 or 3 functions. Those are nothing but the constraints. Constraint function. It can be 1 or more. So let us say if f you wanted to find out the maximum point for minimum or minimum point for this particular function subjected to a constraint given by this. So let us say phi of x comma y comma z is the constraint. Then subjected to this constraint, you need to be finding out the maximum value for this particular one. For example, if you take one particular case wherein suppose you wanted to find out the distance from a point. Let us say this is, so this is the origin point. Now actually this is x plus y is equal to k. Then you wanted to identify the minimum distance between these 2 points. Then this is the place actually you need to be identifying. How you are going to get that? So the distance between these 2 points is x square plus y square under root. So this is the distance between the 2 points subjected to the constraint of x plus y is equal to k. Then it is going to give the distance between these 2 points. So that is the minimum distance between the 2 points. It will give the location of this point. So here actually there is a constraint. So it is not straightforward as if like find out the distance between these 2 points. So you need to be finding out the distance between 2 points subject to the constraint of x plus y is equal to k. In this kind of scenarios, Lagrange's method of multipliers is a best suit for it. Got it? But the same thing if you wanted to do it in the normal method, this constraint needs to be manipulated to put it into the original function f. So here actually see this phi of x comma y comma z. Now what I will do, I will take z on one side and rest of the function onto the other side. I will take that function, put it here, and I will make the function as x comma y. Then I will try to find out the maximum value for that particular x comma y, because the constraint is inherent now in this. Got it? So this is the standard methodology what we are going to adopt it, but it will be very, very complex. Got it? So if 3 or 4 variables are involved, then the complexity will go to an exponential way. So that's why Lagrange's method of multipliers actually it will be a best solution. So that solution what we are going to discuss it now. So here actually to note that one limitation is it is not going to say whether it is a maximum value or minimum value. That you have to identify based on the physical scenario. That is one point you need to note. And the another thing is, so that is there are 2 different functions that are involved in case of Lagrange's method of multipliers. So there actually one function is the function to be maximized or minimized, and the other is the constraint subjected to which we need to be maximizing or minimizing. So these are the 2 important aspects you need to be noting down. Just note down this. I am going to explain the method. Okay. So this Lagrange's method of multipliers. So let us say we have the function f, and this is a function x comma y comma z. Now let us say this is the function u, and we need to maximize or minimize this particular function. U is equal to f of x comma y comma z. Now subjected to the constraint of phi of x comma y comma z equal to 0. Now for this, right? So here actually, if you wanted to find the maximum value or minimum value, so the first derivative has to be vanished. This is a mandatory condition. That is dou u by dou x equal to 0, and dou u by dou y equal to 0, and dou u by dou z is equal to 0. So this is the fundamental condition. Now this fundamental condition, if you find out the partial derivative for this, so dou u by dou x into dx plus dou u by dou y into dy plus dou u by dou z into dz, and this is what we call as du, which is nothing but the total derivative, and this du is equal to 0. Got it? And then exactly in the similar manner for the constraint function, apply the partial derivative. So this is dou u by dou x, dou phi by dou x into dx plus dou phi by dou y into dy plus dou phi by dou z into dz is equal to 0, because right hand side is anyway 0, right? Now here, if you add these 2 together, dou u by dou x plus, so I call this as equation number 1 and this as equation number 2, then what I am going to write here, it is 1 plus lambda times of 2. So lambda is an undetermined coefficient. Undetermined coefficients. So I will explain the importance of this. So this is dou u by dou x plus lambda times of dou phi by dou x times of dx plus dou u by dou y plus lambda times of dou phi by dou x dou y times dy plus dou u by dou z plus lambda times of dou phi by dou z of dz is equal to 0 because RHS part is anyway 0. Got it? Now, if that is equal to 0, independently this part will be 0 and this part will be 0 and this part will be 0. Now here, dou u by dou x plus lambda times of dou phi by dou x equal to 0. This is condition number 1. And then dou u by dou y plus lambda times of dou phi by dou y equal to 0. This is condition number 2. And dou u by dou z plus lambda times of dou phi by dou z equal to 0. And the original condition f of x comma y comma z, phi of x comma y comma z is equal to 0. So this is all the 4 different conditions whatever we have got. So this actually you have to solve all these 4 conditions. So these 4 conditions will give the values for x comma y comma z comma lambda. So 4 unknowns and 4 equations we have got it. Got it? So once you find all the 4 variables, then you will be able to find out the x, y, z. So you already got the x, y, z values, right? These x, y, z values are nothing but the position of the maximum or minimum value point. Directly it is going to give it. Got it? Understood or not? Now here actually this lambda value you may or you may not find out. Why? Because this is a multiplier that got introduced in between to make our work simpler. Now that's why we call this as undetermined coefficient. That means we don't need to determine that. We don't. So while solving all these 4 equations, you can avoid lambda, but you can make use of lambda to simplify all other equations for us. Got it? So that's why this is an undetermined coefficient. You don't need to determine that. So this is why we call this as Lagrange's method of multipliers. So this undetermined coefficient and the function value, whichever is nothing but the subjective condition, right? So these two are getting multiplied together. That's why the name coming as Lagrange's method of multipliers. Suppose if there is one more condition, let us say psi of x comma y comma z equal to 0. If this is also condition, then lambda and one more constant, that is f plus or u plus lambda times phi plus beta times of psi. So dou by dou x, this should be equal to 0. Similarly for y, similarly for z, similarly for, so all the 3 conditions. So here actually two different undetermined coefficients are coming into picture. So because there are 2 constants that needs to be satisfied. Got it? So whatever may be the number of constants we have, all those constants we have to multiply with some random constant and then proceed further to solve it. Now actually here if you notice 5 different coefficients are there, but so 5 different variables are there, but we have one more condition that came into picture. That's why 5 variables and 5 equations. So you will be able to solve all the 5. So this lambda and beta you don't need to find out. You will be using that to solve our equations x comma y comma z. But in between you can avoid those. Got it? Understood? So this is how actually you will be finding out. Now here actually the procedure is straightforward and simple. So form this equation, that is u plus lambda phi plus beta psi. So if it is there, then we will put it. Otherwise just leave it u plus lambda phi, and then take the derivative dou u by dou x plus lambda times of dou phi by dou x, and this equate to 0. Dou u by dou y plus lambda times of dou phi by dou y equate to 0, and dou u by dou z plus lambda times of dou phi by dou z again equate to 0. Along with the 3 conditions, we have original condition, that is phi of x comma y comma z is equal to 0. So all the 4 equations you have to solve it and then find out. So in UPSC usually 1 constant, but in rare cases 2 constants. Rare cases. There is I think only one model with 2 constants. Maybe that we can discuss. Got it? So the complexity will go high if there are two constraints. Got it? Usually one constraint. A rectangular box open at the top. A rectangular box open at the top to have volume of 32 cubic feet. To have volume of 32 cubic feet. Find the dimensions of the box required. Find the dimensions of the box requiring least material for its construction. So this is the problem statement, right? Now here actually two functions needs to be identified first. So one function is the function which you need to maximize or minimize, and another is the constraint. Here actually the box volume is 32 cubic feet. So this was fixed. So he fixed the volume. That means let us say if the box is, this is a open top box. Now this is open top. Let us say this is X and this is Y and the height is Z. Now the volume of the box will be V is equal to X into Y into Z. So this will be 32 cubic feet. So this condition is fixed. So this is nothing but phi of X comma Y comma Z is equal to 32 or minus 32 equal to 0. So this is XYZ minus 32 equal to 0. This is the function phi of X comma Y comma Z. And then this forms the constraint for us. Now for constructing this particular box, so we need the least material. So least material will be, so you will be able to get it provided if you have the least surface area for this entire box. Now this box being the open top, so bottom face and all the four side faces are there. Top face is not there. Got it? So bottom face is the area. So total surface area S is equal to, so bottom is XY plus and the side is XZ. So this is 2 times XZ because this is 1 XZ and the other side is 1 XZ, and then other is 2 times of YZ. So this is the surface. Now, so this is the function to maximize or minimize. So this is the function we are minimizing it subjected to the constraint given by this. Now this one you can form the function, that is dou u by so dou s by dou x plus lambda times of dou phi by dou x is equal to 0. It implies the condition is dou s by dou x is nothing but, so y plus 2z plus lambda times of dou phi by dou x is nothing but dou phi by dou x, so yz is equal to 0. Similarly, dou s by dou y plus lambda times of dou phi by dou y, this is equal to 0. It implies, so with respect to y, if you do it, this is x plus 2z plus lambda times of xz is equal to 0. And the third condition is dou s by dou z plus lambda times of dou phi by dou z is equal to 0. It implies, so this is 0 plus 2x plus 2y plus lambda times of xy is equal to 0. So these are the three different constants we have got it. So this is 1 and this is 2 and this is 3. Got it? Note down till this point. Done? Okay. So here actually, from this actually, multiply this entire equation with x. So equation 1 with x, it implies xy plus 2xz plus lambda times of xyz equal to 0. And it implies xy plus 2xz is equal to minus lambda xyz. Similarly, 2 with y. If you multiply 2 with y, then this will be xy plus 2yz plus lambda times of xyz equal to 0. It implies xy plus 2yz equal to minus lambda xyz. And the third one is z. So this is, so if you multiply third one with z, then this will be 2xz 2yz plus lambda times of xyz equal to 0. From this, then it will be 2xy 2xz plus 2yz is equal to minus lambda xyz. So this is equation number 3 and this is equation number 2 and this is equation number 1. Now here, why I have written in this format is, the right side part actually I made everything 0, so everything same, so that actually I can equate these equations, or actually subtract 2 from 1, then it will be, so xy plus 2xz minus xy minus 2yz, right? So this subtraction so is equal to 0. So it implies, so xy and then 2 will cancel and then x is equal to y. So this is the condition what we have got, right? So exactly in the similar manner, so if you take the other condition, that is 2 and 3, if you take it, so xy minus yz, you subtract it. 2yz will cancel out. Xy minus 2xz will be left over. So xy minus 2xz is equal to 0. So or this is x, you can cancel it out. Y is equal to 2z. So here from this actually this is 2z. So this is how actually we have got the conditions, right? So these conditions, if you notice, x is equal to y and which is equal to 2z. So this is how actually you need to generate the dimensions so that you will get the least material. So these are the constraints for us. Now, if I make x is equal to y and which is equal to 2z, so original equation is xyz is equal to 32. And then I make everything in terms of x, then it will be, so x into z can be written as x by 2 is equal to 32, right? Now x cube is equal to 64. And then x is equal to 4. So if x is equal to 4, then y will be 4 and z will be 2 times of that, that will be 8. So 4, 4, 8. Sorry, y is, so z is equal to x by 2. Yeah, x by 2 is 2. 4, 4, 2. So 16 into 2, which is equal to 32. So done. So this is, so it is satisfying this condition, and the least material that you are going to get it is, that is this surface actually what we have generated. So that surface area, so that is xy plus, so xy plus 2 times of xz plus 2 times of yz. So this is xy is 16 plus 2 times of xz. So xz is 8 into 2 16 plus 2 yz 8 into 2. So this is 16. So 3 times of 16 48 square feet. So this is the least material that we can have it. Got it? So if you change these dimensions, definitely whatever the surface area you are going to get it is definitely more than this. Got it? Understood or not? So this is how actually you will be finding out the minimum value for this particular function. Now actually, so you take one question as the homework. This is the same problem statement. You try to solve with the help of the normal procedure, whatever we have done yesterday. Got it? So this is with the help of Lagrange's method of multipliers. So just took the partial derivatives and multiplied with lambda and then equated to 0 and solved all the equations. We got the values of x, y, z. That is as simple as that. If you notice one important aspect, this lambda value, I didn't even try to find the value of it. I just actually avoided in between. Got it? So that you need to consider that. Got it? So we have avoided in between. That's why this is an undetermined coefficient for us. Note it down. Okay. So you take this as homework by considering this with the normal method without using Lagrange's method of multipliers. Note down one more. Given x plus y plus z is equal to a, given x plus y plus z is equal to a, find the minimum value of x power m, y power n, z power n. Find the minimum value of x power n, y power n, z power n. So you have to find out z power x power m, y power n, z power p. You have to find the minimum value of it. Yeah, this kind of questions were asked in UPSC. Yeah. Yeah. So Anubhav, your answer is correct. So anybody got the answer for this? Well, I think it should not include xy values, right? You have to solve for x, y, z values and then finally put it in the answer. Yeah, that's correct, Ravindra. So that is x value, right? Am by m plus n plus p is the x value. Yeah. So similarly the y values and similarly the z value, and correspondingly you have to put it in the function f of x comma y comma z. So that function is x power m, y power n, z power p. So if you replace those values there, you will be getting the final answer. Got it? So that answer is, I hope I don't need to solve this. So a power m plus n plus p, a power m plus n plus p into m power m, n power n, p power p. Divided by m plus n plus p whole power m plus n plus p. So this is the maximum value. Got it? So anybody wanted me to solve, or we can proceed? It will be the straightforward procedure. Nothing great in it. Got it? So the function actually, so the condition is x plus y plus z is equal to a, and the maximum value for which we need to be finding out is x power m, n y power n, z power p. So here f is equal to, so x power m, y power n, z power p, and the phi value is x plus y plus z minus a, and this is equal to 0. So this is the condition. So you have to find out dou f by dou x plus lambda times of dou phi by dou x equal to 0. Similarly, all the three conditions. But here actually one important aspect what you need to know is, suppose x by a plus y by equal to y by b is equal to z by c. Then let us say this is equal to lambda. Then this is equal to x plus y plus z by a plus b plus c. So this is one of the very, very important formula which you need to know. And this formula we will be using in this particular case. So not only in this particular case, especially when we deal with partial differential equations, so we are going to use this rigorously. So note down this. So this is one of the very important formula. So you can prove that here itself. Why? Because see this, x is equal to a lambda, y is equal to b lambda, z is equal to c lambda. If you put it here, so lambda times of a plus b plus c, a plus b plus c will cancel out numerator and denominator. Lambda will be left over. That means these two are equivalent. So this method actually we are going to use it in partial differential equations. Even here also we will be using the same. Got it? To simplify this particular value of lambda. Clear? Any questions? Note down one more. Find the maximum and minimum distances of the point. Find the maximum and minimum of the point (3, 4, 12). 3, 4, 12 from the sphere x square plus y square plus z square equal to 1. So this is the problem statement. So find the maximum and minimum distances of the point 3, 4, 12 from the sphere x square plus y square plus z square is equal to 1. Now actually this will form the constraint of x, y, z is equal to 0. So this is the constraint. So if you take this one this side, this will be minus 1 equal to 0. That will be the constraint. And then the distance value from any random point on the sphere, located any x, y, z value on the sphere, then the distance between the distance from a random point on the sphere x, y, z to the point so sp square. So why I call this as, this is a sphere and this is a point, so I call this point as s. Then this distance, so this is sp, so this point is x, y, z, and this point is 4, 3, 4, 12. Now the distance sp square is equal to x minus 3 whole square plus y minus 4 whole square plus z minus 12 whole square. Now this is the function, so we call this as the random function f. So f is the function which you need to simplify. I take sp square rather than square root because SP square maximum value or the minimum value and SP maximum value or the minimum value, it will give the same implications. So that's why if you put SP, then actually there will be some root extra that is coming, which will make your calculations tougher. Rather than that, if you take SP square, in our analysis, it won't make any difference. So that's the reason actually we took this format. Got it? Now, so this function, so f actually needs to be maximized or the minimized subject to the condition of, so this is dou by dou. Similarly, dou by dou y of this, dou by dou z of this, and dou by, so all the three conditions along with this original condition, you have to simplify and solve it. This is the homework for you. So in case if you are not able to solve, I am going to solve it for you in the tomorrow's class. Fine. Got it? So tomorrow will be the last class for differential calculus, and day after tomorrow onwards, we are going to start the integral calculus. Clear? Any questions? So Vishal, I think so. These are only the intermediate terms what you are putting in while simplifying. You have to simplify all and then get the final answer, because the final answer will not include these xy values. Yeah. Okay. So any questions? Okay. Yeah. So that's all for today. Yeah. Thank you. Yeah. Good night.